So I've opened up PyCharm and it's gone immediately to the project I was working on last. So all I need to do now to start Jupyter Notebook is to type the command here in the terminal here. That opens up a web browser and shows me the dashboard. So here are the two files that I created in the previous video. There's the data file I'm going to use, and there's that sample notebook. I've also created another notebook here, Basic Skills, which is the one that I'm going to be using for these first tutorials. So just to remind you what a notebook is like, I'll just open this one by double clicking. And that opens it up in a separate tab. Now remember that a Jupyter Notebook consists of these various cells into which you can type either text or code. If you want to type in text, you can do that by selecting Markdown here. It'll probably actually say code initially, so choose Markdown from the drop-down list. And then you can enter text, and you can use Markdown syntax if you know how to use that. Basically, Markdown is where you use little symbols to carry out formatting. So for example, headings can be put in by using a hash sign, one hash for a level 1 heading, a large heading, 2 hash signs for a level 2, which is slightly smaller, and so on. So I could type here, for example, a hash and then say, just put some text in. Now, to run text or code in a Jupyter Notebook cell, you use the keyboard shortcut Shift-Enter. If you press Enter, it just moves down to another line, and that's how you can put in obviously multiple lines of code or text. But to actually run it, Shift-Enter. And as you can see, that's created a level 1 heading, and you can put other text in with Markdown syntax if you know how to use Markdown, which you can easily find out about on the web. It's very straightforward. So notice that the next cell it's moved down to now, that by default will be code, which is most of the time what you want to put in. So I'm going to go back here now to the dashboard and open up this Basic Skills notebook. So this is the one that I'm going to use to illustrate exactly what it says, the fundamental skills that you need to start doing data analysis with Python. I'll be showing you how to import data, how to select rows and columns, how to filter your data. These are all essential things which you often need to do with any data set. And then in future tutorials, I'll move on to looking at more specific examples of data analysis with cross-section data and with time series data. So the first thing you want to do is to load up, i.e. import the necessary packages. Now, if you remember, I pointed out in the first video that the three essential ones that we needed to make sure installed were NumPy, Pandas, and Matplotlib. So you now need to import those, which basically loads all the content of them into memory so you can utilize the various functions and commands in those packages. You do this with the import command, and what you typically do is you say, for example, with NumPy, import NumPy, but then you put as, and you put a little alias for it, which by convention it's NP, which means that you can then refer to functions in NumPy by simply typing NP and a dot and then the name of the function. So it's just quicker than typing NumPy all the time. Similar with Pandas, that by convention that's imported as PD, and again by convention matplotlib.pyplot, which is the part of matplotlib that you need, is imported as PLT. So these are the shortcuts, the aliases we'll be using. So those are the three central packages that we need. So I'm going to press Shift Enter to put these in, or to load these into memory, so that the functions or the commands which are in those packages are now available in what's called the namespace. So next, having done that, the next stage would doubtless be to import your data set that you're going to analyze. Now we can do that using a command in pandas called read_CSV. So I'm going to import this data into a variable called df, and it will read this data into what's called a pandas data frame. A data frame, if you've used R, you'll know what a data frame is. Data frame is essentially a spreadsheet where you have columns which contain the variables and rows which contain the cases or the observations. And each column, each variable can, of course, have a different type. One variable could be numeric data, another one could be categorical data. You can also have dates, which will be used with time series data. There'll also be one column at the beginning, which is called the index, which is what you use to actually refer to specific rows. Now that will be created automatically if you don't indicate what column in your data file you want to use. So here I'm going to simply read in this CSV file. Now because this is actually in my working directory here, then all I need to do is to put in inverted commas. As in most programming languages, any text, any string has to be put into inverted commas. Now you can use either single quotes here or double, as long as you're consistent. I've used single here. Now there could be various options you could add to this if you need to, but normally just reading in the file like this, and particularly if you have it in your working directory, so you don't need to put a path to the file, will do fine. I find that's the easiest way of doing it. So let me run this command, and it will have read that in. We can tell it's successful because otherwise there would be an error message that would come, that would have been printed. Now, as I say, this has been read into a data frame. We can check that that's the case by looking at the data type here. So by using this type function here, I can check, and as you can see, it's a pandas data frame, which is just like a spreadsheet. Now, if you want to know how many rows and columns you've got, how many variables, or how many cases, you can use this thing here, shape. In the commands that you use in Python, in pandas and so on, are basically of two types. They're either functions or they're properties. A function will, like read_CSV, will require some parameters, and if it needs more than one, you separate them by commas. A property, on the other hand, what's also called an instance, doesn't. So here you can see shape is not a function. It doesn't require any parameters. So it's simply the name of the property itself. Now, if you wanted to find out more about a particular property or function, you can do that directly in Jupyter Notebook by simply putting your cursor within the property or function and pressing Shift Tab. And that, as you can see, brings up a nice little help sort of mini pop-up, which tells you what the function or property does. And if it is a function, it'll tell you what options are available, what parameters. It's fairly terse, but usually it's enough to remind you of what something does. And also, let me mention that a way to enter these functions or properties quickly, or indeed find out what's available, is to, if I just delete that, once you've typed the dot, and most functions and properties, as you'll see, use the dot notation to access them. So you put the name of the variable or the object, a dot, and then if you press the tab key, it lists all the possible functions or properties, which are actually called instance as here, but another name is property. Remember, functions will require some parameters, or, well, you might not include any parameters, but you still need to put a pair of brackets at the end, empty brackets if it's a function, but with an instance you don't. And if you were in fact to start typing shape here, notice it quickly finds the one you want, so you could simply press enter here or click on this thing to put the thing in quickly. So that's useful. So there are those two things there. If you want help on a particular function or property, it's Shift Tab. If you want to find out what functions or properties are available, then once you've typed the dot, just press Tab. And also you can start typing the name of the property or function, and once it recognizes it, you can quickly put that in. So what does shape do? Well, it will tell you the dimensions of the data set. So let me enter that. And as you can see, we've got 35 rows here and 3 variables. Now, what are the actual variables? Well, let's have a look at the data set itself. So to do that, simply enter the variable in which the data is contained. Now, if you have a fairly small data set, as I've got here, I'm just using this small data set for illustration purposes, then you'll be able to display the entire data set on screen in your notebook. If it's much larger, if it's got, I'm not sure what the limit has to be before it stops displaying everything, but if you'd say got 200, 300 rows and maybe 20, 30 columns, 20, 30 variables, it's not going to display the whole thing. It will simply show you the beginning few rows and will show you the beginning and final few columns, and similarly we'll show you the final few rows together with the beginning and final few columns. But here we should be able to see the whole thing, and there we are. There are the 35 rows, 35 cases, and the 3 variables, which are gender, which is a categorical variable, just where the categories are male and female, site, where the categories are either Twitter, Facebook, or Pinterest, and this numeric variable, which shows usage in hours per week on this particular site. And notice here is that index column, the index variable I mentioned, this was not in my original CSV file. I didn't need that because it will automatically create that for you, unless you tell it in here. One of the options you can tell is to say use one particular column as the index, but I didn't need to do that. This numeric index is fine. So that's how we read in data now and check on the dimensions. Let's have a look at if in fact it was a rather large data set where you didn't want to display everything on screen, because it would take up well, as I said, it wouldn't actually do that unless you specifically tell it to do it. Normally it would just show the beginning few rows and the final few rows. Another way of doing that is to use this head function here, which enables you to display the first, well, if you don't put any number in here, if you just put some blank parentheses, it will show the first 5 by default, but here I've told it to show the first 10. And there we are, notice the index starts from 0, so 0 to 9, those are the first 10 rows. You can also show the final few rows by using the tail function. Now here I haven't specified a parameter, but notice you must put the brackets because it's a function, not a property. it will by default show the last 5 rows like that. Now, a good command or function to run on your data set fairly quickly is this describe function, which calculates summary statistics of your data set. And that's useful for finding if there's any possible missing values in the data set. Now, here I've used the parameter, the option include equals, and I've set that equal to all. Notice if you wanted to know what other values could be set to the include option, then of course use Shift Tab to bring up the help screen. And if you look down here at the parameters, you can see include is as though you can either put all or none, but that's actually the default. Most of the properties, by the way, most of the parameters, I should say, will have default values attached to them, which will apply unless you actually change them. By using include all, it will provide summary statistics not just of the numeric variable. If I didn't put include all, it would just do it for the numeric variable. But because I put include all, it will do it for gender and site as well. So let's see what we get. And there you can see we've got some summary statistics. Now, for category type variables, it tells you how many there are. It tells you how many unique values there are. Of course, in gender, there are 2, M and F. It tells you which one occurs the most and how many times. So 19 times out of 35. So that leaves with what, 16, if my math is correct, of females. Obviously, none of these things apply here because it's not numeric. So here we've got that for site. Now for usage, of course, which is a numeric variable, these first 3 here won't apply, but obviously the mean, standard deviation, minimum value, the percentiles and maximum obviously do apply. So this can be useful information. Notice also that it's indicating the count of values, and what it's telling us here, remember there were 35 rows in this data set according to the shape. But what we're seeing here is that there are 35 values in the gender column, but there are only 34 in the site and only 33 in usage in hours per week. Now that's telling me that there are some missing values in these 2 columns. In fact, if we go back to the actual data set here, you can see that. If we look here in site, we've got a missing value there, just that one in row 7. No more, because remember the count was 34 rather than 35. In usage, there should be a couple because the count was 33. So we've got one there and one there. What happens is that when you import your CSV file, if there are any blanks in that, so in other words, if you look at the CSV file in a spreadsheet, if any of the cells are blank, it will then, because that's missing, it will then put NaN in there to indicate there's a missing value. So now with a small data set like this, which you can display entirely on screen, you can locate these missing values simply by eye, but in a much bigger data set, it would be much more difficult, which is why using this describe with this option include equals all is a good way of seeing that it looks as though there are some missing values. Now, how can you deal with this? Well, the easiest thing to do is simply to drop those rows with the missing values and store what's left in a new data frame. So I've done that here with this drop missing values function. It's a function, so I need the bracket, but I'm not including any options. I don't need that, any parameters. And notice I'm putting that into a data frame now called df_1. So I'll do that. And then if we just check that, you'll see that those missing values now have gone. There we are, row 7 has gone, row 12 has gone, and row 16 has gone. So all those missing values have now, so we've now got no missing values here, which is better. But one other thing that might occur is that rather than having a missing value in a numeric variable like this one here, a zero, whoever put this data together might have put a zero in for a situation, a case where there was in fact no value given for hours per week. So had they left that blank, that would have appeared as a NaN, as a missing value, and we could have removed it as we've done here. But actually, perhaps they put a zero in because, in effect, the value was missing. Now, that wouldn't be obviously removed by this command because it's not actually missing as such. But it is, in effect, a missing value here. So we really do want to exclude row 30. Now, again, with a small data set, you can look for zeros by eye and find them, but with a much larger one, you couldn't really do that. An easy way to discover if there are any zeros in your numeric variable is to use the query function. And this is something I'll be looking at in the next video to show because you can use this. This is the main way you can use to filter data. So what I put here is remember we're operating now on df_1, so I put dot, and then the function name query, and then in inverted commas, you put something like this. You put the variable name, and then you're saying, look for rows here where usage in hours per week, this variable is equal to 0. Notice the two equal signs here. Equal on its own is what we call assignment. That's for putting data into something. Here, this is a comparison operator. So we need a double equal sign here. If you put a single equal sign, you'll get an error. So this will find any rows where usage per hour is equal to 0. Now, in fact, we know there's just one, row 30. So that's what it should return, which it has. So now we can drop that particular row using this drop function. And I'm going to then put what's left into another data frame here. You could, it is possible to keep it within the same data frame by using an option called, if I can just look it up here, in place. If you set in place equal to true, it will it will drop row 30 from df1 and return df1. It will be the same data frame, but I think it's better to put it into a new data frame, which is what I've done here, df_2. I'm going to drop that row 30, and then I'll finally have a look at df2, and as you can see, we've now dropped row 30 as well. So we've now got a nice clean data set with no missing values. And we can confirm that by running again the describe function with this option include equals all. And there we are, the counts are all the same now, 31. So we've cleaned up the data set so that we're not any problems with missing values.